name is Ishita Suresh. I'm a ninth grader who goes to North Park Secondary School. Today, I will be taking you into a new world of a certain type of technology that has been recently gaining popularity, especially in today's world. This is augmented reality. Now, a few of you might know what augmented reality is, but I'm guessing many of you also don't know what it is. But that's the whole point of this presentation. Today, I will be talking about what augmented reality is, why it was created, how it works, and how you guys can use augmented reality on your own. So let's dive right in. Augmented reality, or AR, is a digital visual display of objects overlaid onto a picture or video of the real world. In simpler words, it is a digitally made objects or numerous objects that is clashed together with the real world. And I keep on stating the phrase real world. This basically means the user's physical surroundings. For example, if I'm in my room, my real world would be my bed, my desk, and whatever else may be in my room. If you could see this GIF that's presented on the slides, you could see that the user's real world might be what I'm guessing is their living room, and right in front of them is a sort of table. Now there's a hedgehog on their table. Do you think that this hedgehog actually physically exists and is sitting on top of the table? Well, the answer is no. This hedgehog is an augmentation, or another word for what I said as a digital visual display of an object. Augmented reality can be shown in a variety of different devices. This includes specialized AR headsets, goggles, glasses, as well as mobile devices like smartphones and tablets. Augmented reality can also be shown on a computer that is attached to a camera. Augmented reality in a more modern level includes a graphic user interfacial augmentation, which in other words is an augmentation of different buttons that the user can click either using their finger or a remote control, and when they click on the button, it performs a certain task that the user wants to do. Augmented reality is known as the gateway between technology and the physical real world. Now, when I'm talking about AR, a lot of you guys might be thinking of the headsets that you would wear in order to enter a totally new world. Now, that's not quite it. You might be mixing AR with VR, but don't worry, this is a very common mistake. AR, or augmented reality, is very different from VR, or virtual reality. Virtual reality, for example, say I'm in my room or in my classroom, but when I put on the headset, I might be in a totally different world. For example, the GIF that is shown on my right. If I'm in my classroom, when I put on the headset, I might be in a greenhouse like it's shown with pandas and foxes and plants hanging all over the place. Whatever is in my real world has no correlation with whatever I'm seeing through the headset. AR is different. I am able to see what is there in my real world, only images and graphics are added to it. Like in this case, the GIF on the left is a game that is overlaid on top of the user's real world, which appears to be an office. Now that we know a bit of the basics of augmented reality, let's see why it was invented. So arguably, the start of augmented reality was in 1957. This was when Morton Heelig, an engineer, made the Sensorama. This was a machine, and its main purpose was to enhance the experience of watching movies in theaters. What it did was it allowed the user to watch any movie, but with vibration, sound, and visual effects added onto it. This really did enhance the experience of watching movies inside movie theaters. Compare it to augmented reality nowadays, it was able to let someone see whatever's in their real world with added enhancements. So definitely you could say this was the first case of augmented reality. Then in 1968, a man named Ivan Sutherland added to Morton Heilig's machine, and he made what is called the head-mounted display. Now this is the first AR headset. What he made allowed the user to see their eye view with an added stationary object, such as an augmentation of a desk or a computer or anything of the sort that is around an arm's length away from the user, which is around how far a computer screen is from a person on average. Then in 1990, a man named Tom Cuddle added the name AR, or augmented reality, when he was working with his fellow colleague in an aerospace company called Boeing. What he invented was a system, and it allowed engineers to be helped and guided when implementing parts of jetliners, which is a type of plane. After Tom Cuddle's invention, augmented reality got known to a lot of scientists and engineers all around the world. Augmented reality from then on started getting developed and got more complex over time. It had more things to do, and the level at which it could do tasks increased. NASA made a software that allowed engineers to navigate the trajectory of flights while in their flighting tests. Then, fast forward a couple of years, augmented reality in print media was made, and then Google's first AR headset was created. In 2017, Microsoft made their first augmented reality software, which is called HoloLens. HoloLens is very commonly used as it is one of the most developed professional augmented reality softwares that we use even today. So why is augmented reality important? Augmented reality is the most practical option for both visualizing objects and enhancing existing objects or the real world. So to dive deeper into that, visualizing objects. Augmented reality is really good for visualizing objects because users can see how a certain mechanical part or any type of object would look and function, instead of either the user would have to just imagine it, or they would have to deal with really expensive or dangerous equipment, or invest in very time-consuming tasks and procedures. An example of this is in engineering. A lot of mechanical engineers might use augmented reality to test out and play around with different augmentations of different mechanical parts to see how they would work together before actually dealing and investing their money into the actual physical mechanical parts needed to build a machine. Next is enhancing of objects. This augmented reality is used to enhance objects in two ways. Either it could give the user extended information about objects that are existing, or it could elaborate on features of the objects. For example, let's take the Global Positioning System, or GPS. If you were just to look around you in the middle of the road, you might be completely clueless. Yes, there are houses and buildings, but what are they all for? Where am I? What if you were to look in that same view, but through the GPS 3D view, you might be able to get extended information like destinations to different places, nearby restaurants, stores, and the names of roads across from you. This is extended information and enhancing the features of objects around you. So where is augmented reality used? It's used in two places: job fields and company softwares. Firstly, job fields, it's used in places like medical training, surgery, aerospace engineering, architecture, archaeology, and many more. One thing that all of these jobs have in common is that the placement of certain objects is vital. Augmented reality is really good for accurate placement and measurements. Next, augmented reality is used in company softwares. Softwares like GPS that I already talked about in the last slide, as well as company stores. Company stores have made softwares that allow customers to have a better experience while online shopping. This is done by pretending that the customer has whatever product that they're thinking of buying. They would test it out, see if they like it or not, and based on the decisions, see if, okay, would I want to buy the product, or do I really think it's not that good? For example, pretend you want to buy a sofa. What you might be able to do to make a better decision on if you want to buy the sofa or not is use, for example, IKEA's augmented reality software. IKEA software can allow you to get an augmentation of the exact same sofa you want to test out and place that sofa anywhere in your room to see how the sofa would look into your room without it actually being there. If you haven't realized yet, this type of augmented reality software is really helpful for people who are online shopping. Lastly, are social media platforms. Though you guys can't raise your hands, how many of you guys use Snapchat? Quite a lot, right? One of the main parts of Snapchat, and definitely the most important feature of Snapchat, is their filters. Filters use augmented reality because it is able to overlay augmentations of cat ears, sparkles, and accessories on top of the user's face. So now we're going to get into a little more detail about how augmented reality works. So first off, you would need an augmented reality software in order to function the whole thing. So these softwares are usually coded in C, C#, C++, and Java, which are all types of coding languages. These softwares have an inventory that have either pre-made augmentations or it has an inbuilt 3D modeling system, which allows the users to create any objects that they want on their own. Next is camera view and visual data. Of course, all augmented reality software need to be connected to a camera because the camera is what the augmentations are being overlaid on. From the camera comes visual data. There are these things called visual markers, and they're able to sense different features through the camera lens. This includes the forward direction, both side directions, what's up, down, corners, edges, and any surfaces that can be sensed. Next is the augmentation accuracy while the augmentation is in display. So there are 3 common methods or techniques that are used for augmentation accuracy. And I'm going to talk about that in the next slide. So the first method is visual key point matching. So there are the pre-made digital visual objects. They have already built-in placement that go with it. Placement basically means, say you have an object, there's going to be a flat surface that comes with it. And what this will do, it would be stored in a database and an algorithm would start running. Now what this algorithm does is it takes the information from the visual markers previously explained, and it will find any flat surfaces that match the slant of the flat surface the augmentation has. And if there are any matches, then the augmentation will anchor itself onto the flat surface found in the real world, and it will just stay there. Next is spatial mapping. It is very similar to visual key point matching. However, the difference is instead of many flat surfaces, a virtual mesh is generated from visual markers. This mesh is a lot more accurate and it's very, very detailed. So digital objects, the augmentations, are able to either arrange or rearrange their placement and proportions and adjust themselves based on wherever the user wants to put the augmentation at. The last technique is device sensors. This technique is vital for all augmented reality softwares because it ensures the accuracy of the movement of the augmentation based on where the user is going. So how this works is the object is anchored onto the device's virtual compass, which is also known as the accelerometer. Because of this, the object can be viewed at different angles based on how the user is moving. This is very similar how a user would look at a physical object that is actually there. As I'm looking there, I could see different angles of my hand, but my hand would just be an augmentation instead of it physically being there. How is it useful? Augmented reality is useful in quite a few ways. First is quality. This usually is used for people who are in the engineering field, as they can build mechanical parts and buildings with a lot more accurate blueprints and measurements. This is because augmented reality can help with measurements instead of the engineer relying on the human calculations instead. Secondly, augmented reality is useful in the MRO. MRO stands for Maintenance, Repair, and Operations. This is engineers who are working specifically on machines. Augmented reality can be used by engineers so that they can make the machine first using augmented reality to predict and prevent any mechanical issues or safety issues that should be considered before actually dealing with the physical parts. This basically ensures success, but in a more safer way. The last point is COVID-19. Personally, COVID-19, the use of augmented reality during then is what got me really interested in this topic. Augmented reality during COVID-19 has allowed businesses to exist virtually. As mentioned previously, a lot of stores have made augmented reality softwares that connect to their online shopping sources so that customers can shop a lot more easier while staying at their houses. It's a lot more practical because instead of taking the time and risk of going to the brick and mortar locations, customers can just stay safely and comfortably at their own houses and pick up the products that they want to buy. Now that I've talked a lot about augmented reality, let's figure out how you guys can get started on using it. So there are many augmented reality softwares that are around the world, and many of them you guys can use with just one download. Now, this could be purely for entertainment purpose, how you're going to use it, but I assure you that once you start using augmented reality softwares, you will definitely get interested in it. So I'm going to talk about 3 softwares that I would recommend. The first one is Apple's augmented reality software. Now, this is only able to be used through iPads, iPhones, in the end, any Apple mobile device. This software allows the user to use pre-made augmentations, and it also has a 3D modeling system built in for the user to make their own objects as well. Apple's augmented reality software is very user-friendly. In other words, it's very easy to use. It is also free, it costs no money. The next one is Vuforia. Now, Vuforia is very well known as it is famous for its high accuracy and very detailed graphics. Vuforia does have a highly complex 3D modeling system, but if you play around with it for a bit, you might be more comfortable. The downside of Vuforia is that it does require you to pay a monthly fee if you want to try unlocking features that might catch your interest. The last one is ARCore, and this is Google's augmented reality software. ARCore has all the features of Vuforia, but it also allows the user to make their own apps that use augmented reality. This can be for home planning or even gaming. ARCore is completely free to use, and you could use this on any type of mobile device. It doesn't have to be Apple or Android or Google. It could be on anything. All of these apps are very user-friendly, and you can use these apps to get started right away. So thank you for listening to my presentation. I hope you were able to learn a lot about augmented reality, and maybe you guys also got an interest like I have as well. Again, my name is Ishita Suresh, and my TeenTalks presentation is about augmented reality. Thank you very much.